Welcome to all students of class 12. In this class, we are solving some questions or solving some problems about transpose of the matrices. Here, a question are given on the board. Question matrix A is a square matrix of 2 by 2 order. Its element is 3 minus 4 and 1 minus 1. We have to prove that A minus A transpose is a skew symmetric matrix. We know that the skew symmetric matrix is that matrix whose transpose is equal to negative of the given matrix. Now, I am going to prove this question. Since matrix A is given that 3 minus 4 and 1 minus 1, then we can find the transpose of this matrix. Therefore, A transpose can exist by interchanging the row and column of this matrix. If we interchange the row and column of the matrix, then we can write A transpose is equal to row change into column 3 and minus 4 as column and 1 minus 1 as second column. Now we can subtract A transpose from matrix A. Therefore, A minus A transpose. Here is 3 minus 4 and 1 minus 1. A transpose is 3, 1 minus 4 minus 1. We can subtract this 3 minus 3 and minus 4 minus 1. 1 minus minus plus 4 and minus 1 minus minus plus 1. It is equal to 3 minus 3 0 and minus 4 minus 1 is equal to minus 5. 1 plus 4 equal to 5 and minus 1 plus 1 it is also 0. Now we can find transpose of the matrix. This matrix means we have to find transpose of A minus A transpose. Therefore, A minus A transpose can be written as 0 minus 5, 5, 0 transpose is equal to 0 minus 5 and 5, 0. If we take common from this matrix, then we can write 0 minus 5 and 5, 0. It is minus A transpose. Hence, we can say that A minus A transpose is equal to minus of A minus A transpose, and hence we can say that A minus A transpose is a skew symmetric. A skew symmetric matrix. It is proved. Now we can prove other matrix. Suppose that a matrix is given and we have to prove that the matrix can represent as a sum of symmetric and skew symmetric matrix. Suppose that a question are given if A is a matrix of element 2, 3 and minus 1, 4. Express is matrix as the sum of symmetric and skew symmetric matrix. Skew symmetric matrix. We we know that if a square matrix A is given, then we can find A minus A transpose and A plus A transpose, and we know that A plus A transpose is symmetric matrix and A minus A transpose is a symmetric matrix, and we can write the matrix A is equal to 1 by 2 A plus A transpose and plus 1 by 2 A minus A transpose. In the previous theorem, we have been did in this formula. So, according to this formula, matrix A can be expressed as the sum of two matrices, and two matrices are such a way. The first matrix is symmetric matrix and second matrix is symmetric matrix. We can write A plus A transpose. First of all, we have to find A transpose from this matrix A. Since matrix A is given 2, 3, minus 1, 4, therefore A transpose can written as 2, 3 and minus 1, 4. Therefore, we can find A plus A transpose. Therefore, A plus A transpose is equal to matrix A 2, 3, minus 1, 4 and plus 2, minus 1 and 3, 4. If we add this, then 2 plus 2, 2 plus 2, 3 plus minus 1 and minus 1 plus 3 and 4 plus 4. Hence, we get 4 and 3 minus 1, 2, 2 and 4, 4, 8. Therefore, 1 by 2 A plus A transpose is equal to 1 by 2 into matrix 4, 2 and 2, 8. We can divide by 1 by 2 with all elements, then 2 and 1 and 1 and it is 4. Now we can find A minus A transpose. The matrix A is 2, 3 and minus 1, 4. A transpose is 2, minus 1 and 3, 4. Then its difference is 2 minus 2, 3 minus minus plus 1 and minus 1, minus 3 and 4 minus 4. And we get 0, 4 and minus 4 and it is 0. Now we can find 1 by 2 A minus A transpose. If we find A minus A transpose 1 by 2, half of A minus A transpose is equal to 1 by 2 into 0, 4 minus 4 and 0. It gets 0, 2 and minus 2, 0. Now we can find 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. Therefore, 1 by 2 A plus A transpose and plus 1 by 2 A minus A transpose. Hence, it is a matrix of order where 2, 1, 1, 4 and plus 0, 2 and minus 2, 0. Okay. The next problem is the matrix A is given. Express this matrix as the sum of symmetric and asymmetric matrix. Here, matrix A is given a square matrix and its order is 3 by 3. Means matrix A have to express in the form of sum of symmetric and askew symmetric matrix, and we know that the symmetric matrix is written as 1 by 2 A plus A transpose or only A plus A transpose. We know that A plus A transpose is a symmetric matrix and A minus A transpose is askew symmetric matrix. And according to formula, we also know that matrix A is equal to 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose, where 1 by 2 A plus A transpose is symmetric matrix and 1 by 2 A minus A transpose is askew symmetric matrix, and matrix A can be interchanged into sum of symmetric and askew symmetric matrix. Now we can solve this. First of all, we have to find A transpose. Since matrix A is given 3 minus 1 0 2 0 3 and 1 minus 1 2, therefore A transpose can be written as by interchanging the row and column 3 minus 1 and 0. Second row interchange into second column 2 0 and 3. Third row can interchange into third column 1 minus 1 and 2. Therefore A plus A transpose can exist. Therefore A plus A transpose is equal to 3 minus 1 and 0 2 0 3 1 minus 1 and 2 plus 3 2 1 minus 1 0 and minus 1 and 0 3 and 2. We can add this 3 plus 3 minus 1 plus 2 0 plus 1 and second row 2 plus minus 1 means 2 minus 1 0 plus 0 and third 3 plus 3 means 3 minus 1 1 plus 0 minus 1 plus 3 and 2 plus 2. Its sum is written as 3 plus 3 is 6 minus 1 plus 2 means 1 and 1 1 0 and 2 1 2 and 4. It is A plus A transpose. Now we can find A minus A transpose. A minus A transpose, it is equal to matrix A 3 minus 1 0 and 2 0 3 1 minus 1 and 2 minus 3 2 1 minus 1 0 minus 1 0 3 2. If we subtract this, then we have to write 3 minus 3 minus 1 minus 2 and 0 minus 1 2 minus minus plus 1 0 minus 0 and 3 minus minus plus 1 1 minus 0 minus 1 minus 3 and 2 minus 2. It is 0. It is minus 3 minus 1 2 plus 1 3 0 minus 0 0 and 3 plus 1 4 1 minus 0 1 minus 4 and 0. Therefore 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose will be equal to half of 1 by half of A plus A transpose. We have to exist. We exist the matrix A plus A transpose, and A plus A transpose can set up at this place. 1 by 2 and matrix 6 1 1 and 1 0 2 1 2 4 plus 1 by 2 A minus A transpose. A minus A transpose 0 minus 3 and minus 1 3 0 and 4, again 1 minus 4 and 0. We can common this matrix 6 1 1 1 0 2 and 1 2 4 plus 0 minus 3 minus 1 3 0 and 4 and 1 minus 4 0. It is sum of symmetric and asymmetric matrix. It is answer. In this problem, there is given two matrices. First matrix is denoted as A and second matrix is denoted as B. We have to verify AB whole transpose. It is equal to B transpose into A transpose. First of all, we have to exist the product of two matrices A and B means AB. First of all, in this problem, we have to find first of all AB means product of matrix A and matrix B. Matrix A is given as matrix A is a column matrix and matrix B is row matrix. Minus 1, 2 and 3 and matrix B is given as minus 2, minus 1 and minus 4. It is row matrix and it is column matrix. We have to multiply column matrix with row matrix and we can multiply as minus 1 into minus 2. First of all, minus 1 can multiply by minus 2 means minus 1 minus 2 means it is only minus minus plus 2. First row and first column completed. Now we have to multiply second row with second column. In second row, we have to multiply first row by second column. First row by second column, then minus 1 into minus 1 and it is equal to 1. And first row with third column, minus 1 into minus 4 equal to 4. Now we can operate the second row from the all columns. 2 into minus 2 equal to minus 4. 2 into minus 2 means minus 4 and 2 into minus 1 equal to minus 2 and 2 into minus 4 equal to minus 8. 3 into minus 2 is equal to minus 6. 3 into minus 1 it is minus 3 and 3 into minus 4 it is equal to minus 12. Hence AB is completed and AB is 2, 1, 4, minus 4, minus 2, minus 8 and minus 6, minus 3, minus 12. Now AB transpose, therefore AB transpose is equal to the matrix by interchanging the row and column of the matrix AB, and after interchanging the row and column of the matrix AB we get 2, 1 and 4, minus 4, minus 2 and minus 8 and minus 6, minus 3, minus 12. Now our RHS we have to multiply it. Therefore, it can written as LHS. For RHS, we have to find B transpose and A transpose. Since B transpose it is equal to the transpose of matrix B is given as row matrix, and hence its transpose will be a column matrix. Then its row can be interchanged into a column and -2, -1 and -4. Now A transpose and A transpose, since A is given a column matrix and its transpose will be a row matrix. After interchanging the column into row, -1, 2 and 3. Therefore, we have to multiply for RHS B transpose into A transpose. RHS is equal to B transpose into A transpose. B transpose is -2, -1 and -4, and A transpose is -1, 2 and 3. First of all, we have to multiply first row from first column. -2 -1 is equal to 2. Again, -2 into -2, -2 into 2, -4. -2 into 3 means -6. Now we can multiply the second row from all columns. -1 into -1, it is equal to 1. -1 into 2, -2. -1 into 3, -3. Now from last row, -4 into -1, it is equal to 4. -4 into 2, -8. And -4 is multiplied with 3 equal to -12. We observe that the value of LHS and the value of RHS means matrix obtained in the LHS and matrix obtained in the RHS, both are equal, both are same. Therefore, we can write that LHS is equal to RHS and the result is true. Now, in the next class, we will read about elementary row and column operation on the matrix. This class is completed.